Hi everybody, welcome to Philosophy 1200. Today should be Monday, April 20th, and we're going to be starting a new unit today. Today's our last week of regular class. What I have to introduce today should only take like one day of lecture, and I think we'll spend the next two lectures doing some practice problems, trying to get you guys familiar with this. It's still proofs, all the fundamentals are still going to be there, all the implication rules are going to be there. We're just going to add a couple more rules, make the proofs a bit more complex. So if you're still having trouble with proofs, it'll be really important to get that down before the exam. The exam will be a week from Friday, and it'll just be like the other exams. I liked the format that we did for last time, so I'll probably do something very similar, maybe make a few changes. So be on the lookout for information about that. And furthermore, I'll be available all of exam week for meetings or questions, email, so feel free to reach out to me. One more note before we get started is I believe class evaluations have been going out, at least for the past week. I don't know if they're still available. I probably should have made this plug earlier, but it would mean a lot to me if you filled out my evaluation. Those make a big difference both for our department and for my personal career. So I don't know, if you haven't filled it out yet, it would do me a big solid if you would fill mine out. So, all right, with that being said, we're gonna get into unit 6, which is about replacement rules. So what are replacement rules? Replacement rules are different than implication rules in that replacement rules are still valid argument forms, but instead of expressing like new information or an inference, they express two logically equivalent statement forms. So a replacement rule allows us to replace any existing statement within a proof. But because they have this special relationship, they allow us to, they can be used in ways that implication rules simply cannot, such as they can be applied to any line in a proof, no matter where it is. They can be applied to any statement within any line. And what's cool about that is that they can even be applied when the statement in question is not the major operator. So previously with implication rules, you know, say we had a conjunction that was embedded within a conditional or something. With implication rules, and we couldn't touch that conjunction until we separated it from the horseshoe. But with replacement rules, if we have a replacement rule that allows us to do something with that conjunction, we can go ahead and do it while it's still embedded in the conditional. That's because they're replacement rules. So when we apply a replacement rule, we're simply restating the statement, we're drawing it, symbolizing it in a different way that's completely equivalent to the way we had it before. Yeah, and they're different from implication rules because they don't give us any new information. They just allow us to restate the existing statement in a new way. On the face of it, that might seem sort of trivial, like why do we need these things? But as we've seen with proofs, we need the symbols to be very specific, we need the symbols to be very consistent, and replacement rules allow us to do that. Yeah, and they sort of change the game in a big way with proofs. So here are the 10 replacement rules. I know I hate to be throwing more rules at you, but some of these are a lot more important than others. And we'll go over which ones are important and which ones are not. Please note that we still have the little p's, little q's, little r's. Those are still statement variables, so you can insert any statement for those little letters, no matter how complex. And you might notice this new symbol, these 4 dots. That just means is logically equivalent to. So P is equivalent to not P. That should be fairly simple. And then another thing that we need to know about these rules is that they go both ways. So, you know, with implication rules, they only went one way. But with this, you know, because they're replacement rules, because they're logically equivalent, they are equivalent with each other. So this not P is equivalent to P. and vice versa. So you can use the replacement rules going one way or going the other way. So I'll be posting all the, like a rule sheet on Blackboard, so you can have that sort of ready to go. But we're going to spend the rest of this lecture today talking about each rule and sort of where applicable, how they work. So the first one is De Morgan's, and De Morgan's is an extremely important and valuable rule. And De Morgan's, we've been through this before when doing translations and such. This tells us that a negated conjunction is equivalent to two negated disjuncts. At the same time, a negated disjunction is equivalent to two negated conjuncts. So I think we've been over this when we have gone over a neither nor or a not both. How we can't just distribute the negation over the parentheses like we would in math. We have to do it this way. So the way I like to think about when we do De Morgan's is we distribute the negation, but after we do that, we then have to flip the sign. So if we had a dot to start with, we have to turn that into a wedge. If we had the wedge to start with, we have to turn that into a dot. That's how we do De Morgan's. A good idea when you're doing proofs is pretty much whenever you see one of these or one of these, think about doing a De Morgan's, because they just aren't that common to show up without needing a De Morgan's. And especially this iteration is pretty valuable, because if you do De Morgan's on this disjunction, now you have two negated conjuncts that you can then simplify and use in your proof. So De Morgan's is an extremely useful rule. It'll probably be one of the most used rules from this replacement rule set. All right, the next one is double negation, that I think we've been over before. Now we're sort of making it explicit, and I think that's it's a fairly intuitive rule. Any statement is equivalent to a double negation of the same statement. At the same time, maybe if you're good at seeing it, you've already seen when a double negation is required and when it's not. Sometimes with a disjunctive syllogism or a modus tollens, you need to do a double negation first. But I don't think you should just use double negation willy-nilly. Usually you see where it's necessary and then you do the double negation. And yeah, just in case you need an example, if I am hungry is H, then it is not the case that I am not hungry, not H. If you think about it, those two statements are expressing the exact same thing, the fact that I am hungry. All right, the next rule is commutation. This rule is very simple, so simple that I think it's redundant. And this just says that within any disjunction, the placement of the disjuncts doesn't matter for the truth value of the statement. And within any conjunction, the position of the conjuncts doesn't matter for the truth value of a statement. So commutation just says, with any disjunction, you can switch the places of the disjuncts. With any conjunction, you can switch the place of the conjuncts. Very simple. If you don't believe me, do the truth table. That'll be useful for, if you don't believe me on any of these problems. But yeah, there have been plenty of times, I think, in proofs where we've sort of done this rule without noticing. That's perfectly okay. I'll have a bit more to say about using this rule later in this lecture. But yeah, commutation, it exists. We use it a lot, but it's so sort of simple and clear that it's not always necessary to make it explicit. All right. Similarly, association is another one of those very simple rules that we sort of have probably used a time or two, but it's so simple that we don't always have to make it explicit. So association just says that with any chain of disjunctions or conjunctions, you can move the parentheses around at will. So these are all disjunctions. So that means that if we switch the parentheses around, the truth value of that statement will never change. And that's true for any chain of disjunctions. You can switch the parentheses around at will. And the same thing applies to any chain of conjunctions. You can switch the parentheses around at will. what's important to notice is that this only applies when the symbols are the same. So it has to be a chain of only disjunctions. Or only conjunctions. If you have conjunctions and a disjunction in the same statement, you can't necessarily use association because that will mess with the truth value. So this is another rule where we've applied a couple times without noticing, and that's, it's not a big deal because it's a very simple and intuitive rule. All right, distribution is kind of a weird one. It's rare, and usually, it's one of those rules where you're staring at a proof for a while and you really aren't sure what move you can make next. And then you start thinking about distribution. It's sort of like the constructive dilemma in that respect, where it's kind of complicated, it's rare, and you might not want to deal with it until you have to. So yeah, distribution just says if you have this conjunction out here with a disjunction as one of the conjuncts, you can distribute that in this way. So here you just add a P, conjoin a P, and then make the disjunct the main operator. And then the same thing applies when you have a disjunct as the main operator. So again, I don't know. This one kind of works weird in natural language, and it's not super common. You'll use it a time or two, but it's just more important to be aware of it and then know how to use it if you have to. All right, transposition is a useful rule. It applies to conditionals, and this just allows us to switch the places of the antecedent and the consequent. But in order to do that, in order to retain the truth value, we have to negate both. So it's a useful rule, especially when paired with other rules, and you will have to use this a good amount. And we can see how the truth value is retained with this example. So if it's raining outside, then the sidewalks are wet is equivalent to, well, if the sidewalks aren't wet, then it's not raining outside. If you think about it, this guy is true for the exact same reason this guy is true. And that's part of what makes them logically equivalent. So if the sidewalks are not wet, then we can be fairly certain that it's not raining outside. Because if it was raining outside, then the sidewalks would be wet. So that's transposition. Again, it comes in handy quite a bit, and it's one of a few rules that deals with conditionals. So keep that in the back of your mind. All right, the next rule that deals with conditionals is the material implication. And this rule is kind of weird. It's one of my favorites just because it's useful. I'm going to make that squiggly a bit more in focus. But this rule is really cool and powerful because it allows us to convert a conditional into a disjunction or a disjunction into a conditional. All you do is you flip the sign and then you negate either the first disjunct or the antecedent of the conditional, depending on which way you're doing it. So another way to write this rule is P or Q ... So here, if we were going to do it this way, it would be not P, then Q. So that's just what's up here sort of in reverse without a double negation. So yeah, this is a really powerful rule because with the addition rule, we have a lot of ways to create a disjunction. And now, technically, since we can create disjunctions willy-nilly, if we use addition and then use material implication on the disjunct we created, now we can create conditionals, which is super powerful, super cool. And again, this rule is tricky, but it's useful. And you might not believe me that these two are logically equivalent, but draw the truth table if you don't. A good example here is either it's sunny outside or I need my umbrella. Well, if you think about it, that's equivalent to if it's not sunny outside, then I need my umbrella. Yeah. So material implication just says that or statements are equivalent to if not statements. So yeah. material implication. Super useful. It'll come up quite a bit. Hopefully you'll get a bit more used to it. Material equivalence, again, is a very rare rule, mostly because it deals with biconditionals. Previously, we've had 0 rules to deal with biconditionals, so I wouldn't blame you if you forgot that they existed. But material equivalence just gives us a way to break up biconditionals, and usually it's in this form that we'll do it. Just because then we can simplify it, we have a bit more to work with. But yeah, I tried to sort of hint at this rule when I first started explaining biconditionals and why they use the words if and only if. Well, they use the words if and only if because, I don't know, you can read this version of the material equivalence as if, that's the if, there's the and there's the only if. So you'll pass this class if and only if you get at least a 60. Well, that's equivalent to the material equivalence here. If you pass the class, then you got at least a 60. And you got at least a 60 only if you pass the class. In philosophy words, passing the class is both necessary and sufficient to get at least a 60. That's expressed in the material equivalence. Alright, exportation, another very rare rule. It's like distribution in the fact that it's so specific that you'll only really use it when you're sort of struggling to think of what to do next. And the conditions for using it are so restrictive that that's okay. You know, it's not often that you're going to see this kind of argument form or this sort of statement form in either form. But it just says that, you know, if we have a conjunction as the antecedent of a conditional, we can move the parentheses over one and then turn that original conjunction into a horseshoe. So not a super common rule, just have it on your sheet and be looking at your sheet and think about exportation if you see either one of these forms or are struggling to think of what to do next. Alright, and then the last rule is arguably the most useless, tautology. And this rule just simply states that you can turn any statement that you already have into a tautology. And yeah, you'll almost never need to use this rule. So yeah, P is equivalent to P or P. P is equivalent to P and P. This sort of works because remember that when we do proofs, we assume that everything on the proof is true. And well, if P is true, then a disjunction of P or P is necessarily true. And same thing with the conjunction. If P is true, then any conjunction you make with P on both sides is always going to be true. So tautology, you know, it works, but I can think of only one time in teaching this class where we've needed to use that rule. So, before we finish up today, I want to just do a practice proof just to show how some of these work. Please note that I'll be posting some practice problems on Blackboard, so please give those a look and try to familiarize yourself. We'll be spending, Wednesday and Friday just doing more practice. So here's our argument. We're still going to be given arguments like we were before, and they always will be valid. So we've got this chain of disjunctions here as our first premise, a negated simple statement as our second, and our conclusion is a conditional. So now that replacement rules are introduced, it might not be like super clear what to do first, because we have a lot more options on the table. It's important that we think strategically and not go willy-nilly in applying replacement rules, because replacement rules, because they don't add new information, they can easily clog up your proof and just create a lot of confusion and lead you astray. So I think especially with replacement rules, you should only really use them when you think it's going to be useful. So yeah, however you want to think about the strategy, just be a bit more mindful when you're doing these with replacement rules. So to start, I'm going to look at my conclusion, and I'm going to see where my conclusion exists in the premises. Well, I see that it exists right here. I see we have a P and we have an R. That tells me that we might be able to do something with that, especially since the P is negated. That has me clued into material implication, which, remember, is if we have not P or R, then using implication, we could turn that into if P, then R. So that tells me that that's probably going to be my final move. But in order to do that, I have to get rid of this S. So how do I do that? Well, this is a chain of disjunctions, and I have the negation of S right here. So that tells me that if I get the S on the right side, I'll be able to do a disjunctive syllogism, and then do my material implication, and be done. So there's my sort of strategy. There's my roadmap. Now I just have to do the right things to get to it. Well, first, I need to switch over these parentheses. I need to move them over to the P and the R so that I can have the S as one disjunct, so then I can do the disjunctive syllogism. So my first move is going to be to do association on the first one, move these parentheses over, so now I have the S by itself. So that clues me in the next move is going to be to do disjunctive syllogism on 2 and 3, and that will just give me this disjunction. Alright. So now I have what I wanted in the first place. So now I'll do the material implication. And that gives me not P then R. I sort of jumped the gun when I outlined this proof. Because technically, when I do the material implication on 4, I negate the first disjunct when I turn it into my antecedent. And my first disjunct is a not P. So if I'm being diligent, if I'm being consistent, then I need to turn this into not P. I couldn't jump the gun and just call it P, even though I know P is equivalent to not P. So this is what I have here. It's almost just like my conclusion, but I need to drop this not. Well, I can do that by doing double negation. And remember what I said at the beginning about replacement rules. We can use replacement rules on any part of a proof, on any statement. We can use it on the conclusion, we can use it on the premises, we can use it on one statement within a premise, and that's what I do here. Even though the negations are not the main operator, I can still use replacement rules on them to do the double negation. And that's exactly what was called for. And now I have my conclusion. So this proof was done in 6 steps. But remember what I said when I was introducing the rules, that some of them are sort of redundant and simple. And I think especially association and double negation are just sort of simple. So I don't think I think plenty of you would just look at 1 and 2 and be like, hey, I could do a double negation. Let's just do it. So with that being said, if you're comfortable with doing every step of the proof and doing the association, commutation, double negation, doing your due diligence and having longer proofs, please go ahead, do that all the time. But if you're getting the hang of proofs and you're like, well, this doing association all the time is a pain in the ass, and it's a waste of my time. I know what I'm doing and I don't need to do this. When you're doing the proofs, if you jump the gun and don't justify either one of these 3 rules, I will not take off points, so long as you do them correctly. So yeah, if you want to do association and a disjunctive syllogism in the same move and not tell me about the association, that's perfectly okay. Because these rules are so simple and so intuitive, I will know what you're doing if you do them. So with that being said, here is a perfectly okay version of how to do that previous proof. So here, In line 3, I just did the disjunctive syllogism. I did the association at the same time. I just know that any chain of disjunctions is equivalent, so I can just do the disjunctive syllogism. And then here in 4, I did the implication, but I also did the double negation at the same time, because I knew that I would get not P, and I can just drop that and turn it into P. So, you know, if you want to do it this way, or if you want to do it in the way I did originally, either one is totally fine. It's totally your discussion which one you do. So, that's it for the lecture today. Please try some of the practice problems if you're having trouble. The first quiz should be live, if not now, shortly. And that's extra credit, so please give it a shot. Don't forget to post on the discussion board this week, and take a look at the extra credit if you want some more attendance points. So, that being said, I'll see you on Wednesday.